Hey math kids, today we're going to talk about surds and other radicals. We're in section 3A in your book, and we're going to do some prerequisite stuff and then go through a few of the examples. Alright, so I think the obvious thing we need to talk about is what is a surd. So first off, a radical is just anything that's written under this symbol. So if I say 2, 4, 6, any of those are all considered radicals. Okay, now a surd, S-U-R-D, so surds, are any of these that are not perfect squares. So they create a irrational number. So for example, square root of 4 is not a surd, because that is a rational number, the number 2. Oops. Okay. And that's probably all we need to talk about before we do this first example. So let's go to example number 1. It says write as a single surd. And so we have part A wants us to do 2 times 3. So the square root of 2 times the square root of 3. We multiply those together, and we get 6 under a square root. And that is a surd because it is an irrational number, and it's involving a radical. The next one is square root of 18 over the square root of 6. And we just divide those like normal. So 18 divided by 6 is 3. Since they're both under a square root, it needs to stay under a square root, and that is a surd. Now we're going to move on to example 2. And it just says write the square root of 72 in simplest form. So I like to use something called the tree method that looks like this. So I just think of any two numbers that can multiply together to make this. So 36 and 2 is just one option. 2 is prime, so I'm going to stop there. But 36 is not. 36 is 6 and 6. And then I am going to keep breaking that down. 3, 2, 3, 2, until all these numbers are prime. Now I need to find pairs. So I have a pair of 2's right here. I have a pair of 3's right here. And then I just have a single 2. So if I have a pair, they can go on the outside, but they become a single number. So these two 2's go on the outside, but they become a single 2. These two 3's go on the outside, become a single 3. And then this 2 right here that's circled in blue has to stay on the inside. Now I just multiply those out. 2 times 3 is 6, root 2, and that is the answer. So we will move on from that. Now we're on example 3, and it just wants us to simplify. It's a root 3. So since these have the same radical, or number under the radical, we would approach this the same way we would approach this. So you guys probably know that that is just 8x. And so this is the same thing. It's just going to be 8 root 3. Okay, now the next one is 2 root 2 minus 5 root 2. We would approach that as 2x minus 5x, which would be negative 3x. Same thing here, negative 3 root 2. Okay, now we're moving on to example 4, and we have 2 root 75 minus 5 root 27. So before we try to do anything that's like this, we want to simplify this like we did with the tree method. And so 75 is 3 times 25, which is 5 times 5. I have a pair of 5s and a single 3. The 5s come out, so I still have that 2 out there, and they become a single 5 because they're on the outside now, and then I leave that 3. Right here, 27 is 3 times 9, which is 3 times 3. Pair of 3s, single 3. Take out the pair, becomes a single, so I still have my negative 5 times 3. Then this 3 stays on the inside. Okay. Now I want to multiply these together, so I get 10 root 3 minus 15 root 3. Since the number under the radical is the same, we treat it like an x. Okay. So it's just 10 minus 15, so that's negative 5, and then put my x, in quotes. And that would be our answer. Okay. Moving on to example 5. Let's see. Let's get a different color. Let's do root 5, 6 minus root 5. And we will distribute. So if we multiply something under a radical and something that's not under a radical, we actually just write them next to each other. It's similar to trying to do x times y, it just becomes x, y. Okay? Now if we have the root 5, if they're both under a root, we actually multiply them out. So that's 25. Now we simplify that. So the square root of 25 is just 5. So we get 6 root 5 minus 5. And that's it on that one. And then there's a part B on that one. So we have 6 plus root 3 and 1 plus 2 root 3. And we just do this. So 6 plus 12 root 3 plus root 3. I'll move over. And then this times this would be 2 root 9. Okay, and then we just simplify. So 6 is fine, 12 root 3 is fine, root 3 is fine, and then this is this piece turns into a 3, so it's 3 times 2, so it's a 6. And then we simplify it just a little bit further, so we add these two together. 6 plus 6 gives us a 12, and then 12 root 3 plus root 3, which there's really a ninja 1 right there, right? So that's 12 plus 1, which is 13 root 3. Once again, we can combine these because they both have a root 3. Okay, and one more example. We do 5 minus root 2 squared. So it's going to be similar to that last one, 5 minus root 2 times 5 minus root 2, because that's what squaring means. Do not try to distribute that there. So we do 5 times 5 is 25, minus 5 root 2, minus 5 root 2, and then plus root 4. We simplify that, we get 25. Combine both these, negative 10 root 2, and then root 4 is really just a 2. Combine it with the 25, 27 minus 10 root 2. And there's a part B on that one. Just need some space right here. And we get 7 plus 2 root 5, and 7 minus 2 root 5. So 7 times 7 is 49. 7 times this one is going to be negative 14 root 5. This times this will be positive 14 root 5. And then this times this will be negative 4 root 25. Root 25 turns into a 5. 5 times negative 4 is negative 20. These cancel each other, and so it's just 49 minus 20, which is 29. Now, I just want to state one more thing. These are what are called conjugates. They look exactly the same, but the second part has a different sign. So a plus sign here, minus sign here. In that case, you can actually just multiply the first two together, get an answer, multiply the second two together, get an answer, and then simplify, and you'll end up with the same thing. Once again, that only works if they are conjugate pairs. If you have any additional questions about conjugate pairs or anything else, you can come to Math Lab, and that's all I have on this video, so calculator.